Good day, students. This clip, we're going to be going over two examples on how to graph parabolas given standard and general forms. All right, so let's go ahead and write down the equation for the first problem. So for number one, we're to identify a given conic. Find a given conic. Find the properties. And then graph. Label completely. And state the meaning. Okay. Label completely and state the meaning. All right. Now let's go ahead and take a look at the equation. Equation under consideration here is x minus 2 squared equals negative 12 times y plus 2. Okay. Now this formulation right here is a standard form. Okay. For the standard form, you have the squared quantity by itself, and then you have the other quantity on the other side with a constant in front of the parentheses. Now, what conic is this? This has only one square. If you have a conic section with only one square in two variables, then it is a parabola. Okay, so this conic is a parabola. Now let's go ahead and write down what kind of conic this is. Conic is a parabola because you have only just one square. Parabola. Okay, now for the parabola, we do not have a center, we actually have a vertex. Okay, so let's go ahead and write out what the vertex is. To find the vertex is the same procedure for finding the center. You just take the opposite of the numbers next to each variable. So opposite of negative 2 is positive 2. Opposite of positive 2 is negative 2 for the y-axis. All right. Now, next thing we want to consider is an opening. In what direction does our parabola open? Now you want to note that the variable that's not squared, that's the variable that the parabola opens around. Okay, so if you notice, x is squared, so it doesn't wrap around the x. Since y is not squared, that means the parabola is either going to be wrapping around the positive x or wrapping around the negative x. So it's either going to open up or open down. So the opening always goes in the direction of the variable that is not squared. Okay, so since we have a minus here, that basically means that our parabola is going to open downwards. Basically, it's going to be a side facing parabola type situation. Okay, all right, so it opens down. Now we need the p for the foci. Remember, it has c for the foci for the others, but this one has p of p for the foci. So how do we find that? P for the foci. All you just do is you solve the equation a equals 4p. Okay, what is a? Well, the coefficient that I factored out of the parentheses that's unsquared is usually our a, and we say that equal to 4p. Okay, so if a equals to 4p, that implies that our a value is negative 12. Negative 12 equals 4p. Okay, so if I can solve for p, that will be the p of the foci that I'm speaking about here. So I select p, we divide both sides by 4, and that yields p equals negative 12 over 4, negative 3. Okay, so to graph our foci, we have to follow this sign and also this number. Since our parabola opens down, our p of the foci is going to follow the direction of the opening. So in this case, it's going to be 3 units down from the vertex. Okay, we're just going to go 3 units down for the vertex to graph the p for the foci. All right, and then the actually p for the focus. I'm sorry. So this is p for the focus because we have only just one focus in this problem. P for the focus. All right, now next thing we need to find is the directrix. Directrix. And what direction is the directrix? The directrix is always basically the opposite of the foci. So since the focus is 3 units down, the directrix is going to be the opposite, which is going to be 3 units up from the vertex. That will yield, tell us what, how to get the equation of our directrix. Okay? All right, now that's basically all the information we need to generate our curve. So let's go ahead and graph it. 2, -2 are going to the right and down 2, so that's going to be in the fourth quadrant. So let's make our fourth quadrant sufficiently large to accommodate for that shift. So shift my y-axis to the left and my x-axis up. And then this is my x, and this is my y. All right, so let's grab the center, 2, -2, 1, 2, and down -2, 1, 2. All right, so there goes your center. Now let's graph it. All right, so there's our vertex. So now our parabola opens downwards. We're just gonna make a sketch. We don't really care too much about the y-intercept. We just sketch it using that orientation. Just sketch a parabola opening down as best as you can, something like that. Okay, now next thing we're going to graph is the focus. All right, focus is 3 units down. So starting from the center, we're just going to go 1, 2, 3. Okay, note this is -2, right? All right, so this is our focus right here. Let's go ahead and label it. So this is our focus. What are the coordinates of the point of our focus? Our focus is going to be, well, let me start with the center. With the vertex, that'll help me also to verify the accuracy. So this is the vertex. The vertex is 2, -2. So for the focus, I'm going down 3 units. So I'm subtracting 3 from my y since I'm going up and down. I'm going down, so it's going to be 2, -5. All right, either you can subtract or you can count from your origin. 2 to the right, 2, down 5, 5 for your focus. Now, next thing we're going to graph is the directrix. The directrix, remember we talked about that, is 3 units up. Directrix is going to be a line. So we're going to have 1, 2, 3. This is a point that is contained in the directrix. So we're going to draw a directrix like this, side to side, perpendicular to the axis of symmetry. So there goes our directrix. Let's go ahead and label it. This right here is a directrix. And since it is a horizontal line, it is going to be of the form y equals, the y value it intersects here is 1, y equals 1. Or you can just add 3 to -2 and you end up with 1. That goes the equation of the directrix. And then the axis of symmetry is this line right here that goes through these 2 points, the vertex and the focus. Okay, this is the axis of symmetry. Let's go ahead and write down the equation of our axis of symmetry. So axis of symmetry is going to be x, since it is vertical. We're going to look at it's going to be an x equation. So it's going to be x equals, and we'll look at our vertex 2. So it's going to be x equals 2 for the equation of the axis of symmetry. All right, so there goes the graph of the parabola. All right, let's go ahead and take a look at question number 2. In this case, we're going to be dealing with a conic in general form. Okay, so for question 2, we have the situation. We'll have the equation -4 y squared minus 8x plus 8y plus 12 equals 0. Okay? All right, now if you look at this, this is in general form. So we're going to have to convert this into standard form before we can find the properties and then graph the resulting conic. So what kind of conic is this? If you take a look at this, we have 2 variables, x and y. Well, only one of the variables is squared, namely y squared. So what does that mean? That tells us that This is the equation of a parabola, okay? So this is a parabola. Now let's put this in standard form first, and then we can go ahead and find the properties. For the equation of the standard form of the equation of a parabola, let me write it on the side, just for reference. The square is always on the left side, so it's basically y minus k square equals 4p x minus h, like that. All right, so this is the standard form for the equation of a parabola. So what it requires is that the variables be separated. You need the x, the y's on one side, and then everything else goes on the other side. Okay, and then the goal is to complete the square on the left side and just have a y quantity square on the left side, and everything else goes on the right side. Okay, so to accomplish that, let's put the y's together. So I have a y squared and a y right there. Place them next to each other. We have negative 4y squared plus 8y, and then everything else gets tossed to the other side. So I need to move 8 over to the right and also negative positive 12. So let's add 8x and subtract 12. Okay? Alright, so there we have, like, that gives us, this is equal to 8x minus 12. Alright, now let's complete the square and the y world right here on the left side of our equal sign. If you notice, we have a coefficient for the y squared. That's a problem. We need to address that. So to address that, we're going to factor out negative 4. Factor out negative 4. And then we're going to be left with y squared. Now what sign is this going to be? Remember, every time you factor out a negative, the sign, the interior sign changes. Anytime you factor out a negative from a term, the sign changes. So minus divided by a plus is going to be a negative, so it's going to be minus 2y. Okay, so you have to be careful with that. And then let's leave this alone, 8x minus 12. We have to focus on completing the square here first before we do anything to the right side, all right? All right, now to complete the square, we have only one incomplete square, namely b of y. So remember, to complete the square, b of y is negative 2, you do b over 2 square. So b of y is negative 2, so what do we do with that? We divide that by 2, which equals negative 1, and then you square it. When you square it, you have 1. Okay, so that's what I'm going to add to the left side to complete the square. So we have negative 4 times y squared minus 2y plus 1 equals 8x minus 12. Now what am I going to add to the right side? We have negative 4 times 1. Negative 4 times 1 is negative 4. So that's what we put over here also. Negative 4 times positive 1. Alright. So now we are going to have a perfect square trinomial in the parentheses here. Bring down the negative 4. Negative 4 times. You read the first and the last. I can normally do. And bring down the middle sign, okay? So root the first and the last term, and then bring down the middle sign. So that's going to be y minus 1 quantity squared, okay? Equals, here we have 8x minus 16. All right, note that for the standard form for the equation of a parabola, you do not have any coefficients in front of the parentheses, right? So we have to take care of this. So what we're going to do is basically divide everything by negative 4, or we can factor out 8 first and then divide by negative 4. So how about we just divide everything by negative 4 while we're at it? So divide this by negative 4, divide this by negative 4, and divide it by negative 4, and divide that by negative 4 also. Okay? Alright, so what's that going to yield? We're going to have the negative 4 is divide out. We have y minus 1 quantity square. Now anytime you divide by a negative, you know the sign changes. So this one reduces to negative 2x, and this minus over minus, slash and dash, plus 4. Okay? Alright, now we have to factor out, our x cannot have a number in front, so we have to factor that out. So let's go ahead and factor that out. We're going to factor out the negative 2. So we're going to have y minus 1 quantity square equals, factor out the negative 2, we'll have negative 2 times x. Note, whenever you factor out a negative, this sign has to change, right? So this is going to be x minus 2. Alright? So this right here is the standard form. Standard form. Okay, now that we have the standard form, we can go ahead and find the properties. First thing we need is the description of the conic. So what kind of conic is this? We have only one square, so it's called a parabola. Now, next thing we need is the vertex. We don't have any centers for parabolas, right? So the opposite of the number next to the x is negative 2, so we have 2. For the x coordinate, opposite of the number next to the y is 1. There goes your vertex. Next thing we need is a p, actually the opening, so we can know what orientation to place our p. What is the opening? In what direction does our parabola open? Okay? Y is squared, hence the parabola is going to be wrapping around x. The parabola wraps around the variable that is not squared, the unsquared variable, okay? So it's going to be going either to the left or to the right. Since you have a minus here, that means that our opening is going to be to the negative x. So it's going to be opening to the left. Our parabola is going to look something like this. Okay, opens to the left. All right, now P for the focus. P for the focus, we just simply solve the equation A equals 4P. Okay, so in this case, A, this is our A right here, A is negative 2. This is A. So to solve this implies that negative 2 equals 4P. So to get P by itself, we divide both sides by 4. Divide both sides by 4, and our final result is going to be P equals negative 1/2. So what does this mean? It means that if we want to graph the P of the focus, it's going to be 1/2 units to the left from the vertex of the parabola. All right. Okay. Now, next thing we need is the directrix. Directrix. In what direction is the directrix? Well, since the P of the focus goes 1/2 units to the left, the directrix is going to go the opposite direction, which is 1/2 units to the right. Okay, so that vertical line will be our directrix. Okay, now let's go ahead and generate our graph. 2, 1 is the vertex of our parabola, which is in quadrant 1. So we're going to make quadrant 1 sufficiently large to accommodate for this. And if you notice, our focus has 2 as a denominator, as a fraction of 2. So, and it's going side to side. So how about we calibrate our x-axis by halves? Okay, so we'll make this 1, and then make that 2. So, say that again. So make that 1, and then make that 2. Okay, and then for our y-axis, we could do the same thing. Doesn't really matter. So right there, that's 1. So our vertex is 2, 1. There goes our vertex. Now, where do we open? Opening goes side to side. So to draw a parabola, we just graph it side to side like this. It's just a sketch, not perfect. As best as we can. Make it equal length, so it looks good. So there goes our parabola. Okay, now let's label. So first thing I'm going to label is the vertex, but let me draw the axis of symmetry first so I'm not overlapping stuff. So this right here is the axis of symmetry, just to get my orientation together. Okay, so vertex is right here. This is a vertex, so let's put it over there. Use a different color. All right, so this is my vertex. What are the coordinates of my vertex? Is 2, 1. Next point I want to graph is a focus. For the focus, we're going to go 1/2 units to the left. So every tick mark is a half, so this will be my focus right here. Okay? Let's go ahead and label that. So this piece is our focus. Okay? So since we're going 1/2 units to the left, we're going to subtract 1/2 from the x-axis because the side-to-side movement is along the x. So if I subtract 1/2 here, it's going to be 1.5, and the y stays the same, 1.5 comma 1 for the coordinates of your focus. Okay? Now next I'm going to graph is a directrix. For the directrix, we're going to go 1/2 units to the right to this point right here. So that's going to be the directrix. It's going to be a vertical line. Let's go ahead and sketch that. Goes the vertical line. Okay, so there goes your vertical line. All right, now what's the equation of this vertical line? Since this vertical is going to be an x line, so let's label it. So this is our directrix. Directrix is going to be x equals 2.5. Remember, we're adding 1/2 to 2, okay? As indicated here. So there goes our directrix. All right, now the last thing we're going to label is the axis of symmetry. So this line right here is your axis of symmetry. Axis of symmetry. And since it's a horizontal line, it's going to be of the form y equals the y coordinate of your center, which is 1. Y equals 1 is your axis of symmetry. All right, now let's go ahead and write down the meaning. What does all this mean? I didn't write that for the first example, so let's go ahead and write down the meaning. So the meaning is as follows. The locus of points on a plane whose distance from a fixed point the fixed point is the focus, okay? From a fixed point 1.5 comma 1 and the line is going to be the directrix, y equals 1. If the distance from the fixed point to the line is a constant, okay, is the same, not a constant, is the same, is a parabola with the equation the original equation for -4y squared plus 8y minus 8x plus 12 equals 0. All right, so that's that. All right, let's go ahead and write down the meaning for number 1. I kind of skipped that, so let's go ahead and write that in. So meaning, the locus of points on a plane whose distance from a fixed point. The fixed point is the focus, right? From a fixed point to -5, and the line, the directrix, and the line y equals 1 is the same, is the parabola with equation Let's see, the equation is the original equation for problem number 1, which is x minus 2 squared equals negative 12 times y plus 2. Okay, so there you have it. That's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking out here, and click like if you like this video clip, and post a comment to let me know what you think. More clips can be found on mypurserve.com. Thanks again, and have a wonderful day.